This question is minimum genetic mutation. So a gene string can be represented 8 character and is chosen between A, C, G, T. So you are supposed to have a starting string and ending string, and where one mutation is defined as one single character change. And you have a string array code bank that is record all of the valid genes mutation, and you want to give so you want to return the minimum number of mutation that needs to be mutated from the starting to ending. So this question is BFS, pretty straightforward. So what you should do is you're going to traverse the starting string from started gene, and then for every single character you're trying to basically mutate from all this character, and then you want to see once you change. So for example, A C C G G T T, right? You can change to C A C C G G T T, and you want to check is this string inside the bank. If not, then you are going to skip. So the next one will be G, right? So G A C C G G T T is in the bank. No, then you keep changing to T. Is T A C C G G T T is in the bank? No, then you are basically revert this and then change the second one, and so on, right? And then you are trying to make sure the string that you modify is going to be in the bank, and then you want to make sure this will later on map to the ending string, and then you want to return the number of the mutation that require to change from the starting to ending. So yeah, this is pretty straightforward. So what you need to do is, since this is a string array, we're going to make sure there's going to be a hash set. I'm going to say banks equal to new hash set, and this will be array as this bank. So when I check in the string, it's going to be constant, and so if my bank does not contain the ending string, then I'm going to return -1. So yeah, that's pretty much it. So I'm going to have a starting string, and then starting string will starting with starting, and I want to make sure if the current string I visit, I don't want to come back again, you know. So it's going to be set string sync new hash set, and this thing will add the starting string, and then I'm going to traverse, right? So I will do this. So string, I'm trying to, so for every single step I will increment by 1, and when will I pause? I will pause when the queue is empty. And if I did not find, I will just return -1. So I will have a level size. I'm just called size is fine. It's going to be q.size, and I will traverse based on the size, so that in the current iteration I only traverse the current possible string. I'm not trying to traverse all of them. And in the meanwhile, I need to create a public static final char array for the basis that is associated to list. Okay, and for list each traversal, I'm going to just pop the queue, and then I want to make sure if my queue is equal to, if my current node is equal to the ending 1, I would say, oh, I found it, and return a step. So that's pretty much for the scenario where the string is in the queue, and then you are comparing with the ending string, and then it map, and then you return a step. So for example, you're starting from here, and this will be the only character you want to modify, right? So I will have another generate, I'm going to say generate neighbors that require the current node, that require the queue, that require a sim. What else? They also require banks, basically like this. So in this scenario, I would, since this is not map in the beginning, so I started from here, and the first iteration will be, size is equal to 1, and then the node would be exactly the same as this, and then it's not equal to the end genes. So I create a neighbors which is going to be all possibility that is going to be generated by this, and I'll push into the queue, and then since if I change this character from T to A, it's definitely in the bank. I'm going to compare with the ending string again, and if the ending string are the same, I return a step, and in the meanwhile it's already increment on the next iteration, so I don't need to do that. I do another iteration for increment. So I will say generate neighbors that will starting from the current node, that will start from the queue, that will also have the set for string, it's called sim, and then that will have another one called banks. So I will converting the node, so I'm going to char equal to node to char arrays. Then I will have a position, so in post what becomes this, actually this would be array, would be fine. So in each position I'm going to traverse and try to make sure I am able to update. So I need to update, right? But before I update, I need to make sure this is going to be my original chart, and then if I'm on the second index, I need to make sure I don't have the old cache value. So this will be original, and I will do the traversal for the base. I think it's called this. So in each traversal, I'm going to update the base for the current position, and after this, I'm going to reset, right? So this will be pretty much it, and then I will do this. If my base is equal to original, so it looks like it has to be char, right? Because the char array, and then if they are the same, I don't need to change anything. I only need to change when they are not the same. So if a current position that was equal to the base, and since this is char array, I need to just make sure I convert to the string. If is in the bank, contains is in the bank, and not, I haven't traversed the current string, then I would add the string into the queue, while also add the neighbor, which is going to be into the sim. So yeah, it is going to be the solution. Possible. Oh. Yeah. So yeah, this is going to be pretty much the solution. What you can do is this. I'm not encouraging you to do it, because add is going to be a boolean method. If the neighbor is already in the sim, it will return false, or otherwise it will return true. This is like the readability problem. I don't recommend this, but if you want to shorten the code one line less, you can do this. So alright, for time and space, this is going to be a space, this is going to be a space. The worst case for the space is going to be all of B. B represents the length of bank. The time will be all of the worst case is going to be all of B as well. Like you won't be able to generate something that is not in the bank, right? So the worst case is going to be all of B for sure. So there's a solution. Alright, see you later, bye.